Hi friends, welcome to Network Cloud Technologies. So I am Gurdeep Singh Sandhu, your trainer. So today we are going to study storage management part 2, understanding data store file system. So today we are going to study data store file system formats and storage type at the virtual machine logical level. So let's start with the data store file system. So we talk about a data store file system. So when we are having or getting the lunch from the storage team, so at that time we can create a data store file system. So a data store, what we are going to create, so it can have the virtual machine file system, means VMFS, or it can be as the NFS, vwall, and vSAN. So that depends on the technology from where we are getting the data store. So if we talk about the virtual machine file system, so in the virtual machine file system, uh, data store file system, so we are having VMFS 3, VMFS 5, and VMFS 6. And if we talk about the NFS, we are having two versions, NFS 3 and NFS 4.1. Now talking about the data store hierarchy. So data store, it can be of the virtual machine file system or NFS file system. So virtual machine file system. So if we are going to create a data store of VMFS type, so that kind of data store, it can be obtained from the DAS, means your direct attached storage, FC fiber channel over Ethernet, and iSCSI. And NFS, it can be obtained from the NAS. Talking about the virtual machine file system 6. So here we are going to compare 3, 5, and 6. So first of all, talking about the supported SXI version. So version 3, it supports every bit of and every kind of SXI versions, and 5, it supports 5.x and 6.x, and virtual machine file system 6, it supports the 6.5, and virtual machine file system data store up to 64 TB, so it can be created in the 3, 5 as well as 6. And virtual machine decay means your VM decay file. So the disk that can be attached to the virtual machine here. So here we can attach larger than 2 TB. So that is not possible in the 3, but it is possible in the 5. But when we are going to use vSphere versions greater than 5.5, means your 6.0, 6.5, and 6.7, and your virtual machine file system 6. So if we are using data store of VMFS 6, then we can create VMDK more than or larger than 2 TB. And unified block size UBS 1 MB. So it is not present in your 3, and it presents in the 5 as well as 6. So ATS means atomic test size, test and set. So it is not present in 3, it is present in 5 and 6. Sub blocks to store the smaller size files. So up to 64 KB, so it is present in 3, 8 KB it is present in 5, and 64 KB dynamic it is present in 6. So small file support. So small file support is not present in the 3, but it is present in 1 KB in 5 and 1 KB in the 6. So if we talk about the disk partition size, so there are two types of partitions. One is MBR and second is GPT, means GUID, means your grand unified ID partition table, means GPT. So MBR and GPT or legacy MBR, it is present in the 5, and in 6 we are having GPT only. So physical block size 512N, 512N, and in 6 we are having 512N or 512E. And automatic space reclamation. So whenever we are going to delete some virtual machines from the data store, so at that time, so we can have the automatic space reclamation, and it is present in the virtual machine file system 6. So it is not present in 3. Yes, it is present in 5, but we have to apply the manual method. Now further talking about the virtual machine file system 6. So two new internal block size concepts for file creation is present in the 6, and that is the LFB, means large file block with a size of 512 MB, and small file block with the size of 1 MB. And these are used to back files on the virtual machine file system volume. So it should be noted here that the virtual machine file system block size remains 1 MB sized. So thin disks are backed by the SFPs, and your thick disk means your lazy zeroed as well as the eager zeroed. They are blocked by the LFBs, means large file block. So thin, they are backed by your SFB, means small file blocks, and whereas the thick provision disk, they are backed by the large file blocks. So SFBs are used for the portion of the disk that does not fit into an LFB. So upgradation from 5 to 6, it is not supported. So here we have to create the virtual machine file system 6 type of data store, and then we have to migrate all the virtual machines that are present on the VMFS 5 to the VMFS 6 data store. Now talking about the NFS. So NFS type of data store, it can be created with the two types of file system. One is 3 and one is 4.1. Now talking about the NFS, so for an NFS 4.1 data store, you have to provide serverless authentication if required. And NFS-3, it uses one single TCP connection between client and server. So iSCSI does not support multipathing in the 3. And here only one solution is to work with more IPs at the storage side and use link aggregation. So NFS 4.1, it provides the multipathing for servers that supports the session trunking. So when the trunking is available, so we can use multiple IP addresses to access the single NFS volume. And client ID trunking not supported. So storage vendors usually detail the required configuration to provide better scalability, resiliency, and if possible, specific tuning could be requested. So virtual disk created on NFS data stores are thin provision by default. So here we are not getting the thick provision. So here thin provisions are is possible by default. To have thick provision VMDK as well, so we have to use the VAI compatible storage that supports the reserved space operation. So VAI will be discussed later. A difference between NFS-3 and NFS-4.1. So iSCSI compatibility. So since version 3, so all the iSCSIs are supported, and in 4.1 only it supports the 6.x. And NFS security type, so all system it is there in the 3, and in 4.1 both the all system as well as the Kerberos security is supported. And hardware acceleration, so VI NAS, so whenever we are using 5.1 5.5 means above 5.0, and here the VAI NAS is already there. So multipathing it is not possible in 3, it is possible in the 4.1 IPv6 port. So both the versions they are supporting IPv6. And file locking, so for the file locking, .lck file ID is there, and here the share resolutions are present. Now storage type at the virtual machine logical level. So when we create a virtual machine and provide the disk to the virtual machine, and that disk it can be of the VMDK type. And now there are three types of virtual machine disk kernel or VMDKs are present. So first is the thick provision eager zeroed, thick provision lazy zeroed, and thin provision VMDK. So talking for the first type, thick provision eager zeroed. So in the thick provision eager zeroed, all the space is allocated and the data is formatted. So what the previous data is present on the disk, it is deleted and formatted at the time of disk creation. So the entire disk space is reserved and unavailable for use by other virtual machines. So eager zeroed at the time of creation, it takes a longer duration as compared to other formats. Not talking about the your thick provision lazy zeroed. So only difference is there. So in the thick provision lazy zeroed, formatting is done when the data is written to the disk, and same like your thick provision eager zeroed, all the space it is reserved and it is not available to other virtual machines for use. So only the difference between eager zeroed and lazy zeroed is that only the formatting difference is there. So in the eager zeroed at the time of disk creation, so formatting is done, and but in the thick provision lazy zeroed, so when the data is written to the disk at the time of data writing, the disk is formatted. Okay. And in the thick provision, So data write is somehow it is slow, we can say. So this process increases the IOs, means input output per second on new blocks compared to the eager disk. The entire disk same. The entire disk is reserved and unavailable for other for use by the other virtual machines. So whereas the your thin provision VMDK space is allocated and zeroed only on the demand when the data is written on the disk. So unused space it can be available for use by other virtual machines also. Now storage type at the VM physical level. So to access a block device such as virtual disk, VMDK, virtual CD, DVD, ROM, or other SCSI devices. So each virtual machine uses storage controller. So at least one is added by default when we create a virtual machine. So here we are talking about the controllers that are used by virtual machine to access the VMDKs or the disks. First is the bus logic. So first emulated SCSI virtual controller available in VMware ASICs. So legacy controller used for legacy operating system does not support VMDK larger than 2 TB. So bus logic, if the virtual machine is using the bus logic, so then we are unable to create virtual VMDK file larger than 2 TB. And second is the LSI logical parallel. So SCSI virtual controller, formerly known as LSI logical, used for Windows Server 2003. Now talking about your third one, LSI logic SAS. So this kind of controller, so it was introduced in vSphere 4.0 evolution, and it is the evolution of the parallel driver. So working as a SAS virtual controller used in Windows Server 2008 or newer versions. Now talking about the VMware Para Virtual or PV SCSI. So it is a SCSI virtual controller introduced in the vSphere 4.0, and it is designed to support very high throughput with minimal processing cost. So working not on emulation mode but in para virtual mode, and it requires the VMware tools to be you recognized or configured. And if we talk about the iSCSI SATA, so it is introduced in the your vSphere 5.5, and now talking about the NVMe. So it is the latest one. So NVMe it is used with the 6.5 and the virtual machine and hardware version 13. So whenever a virtual machine is created with the version 13 or your SXI host 6.5 is there, so then this kind of controller it is used by the virtual machine. So here the get your guest IO processing is overhead reduced by the 15% as compared to the SATA disk, and which allows more virtual machines per host or more transactions per minute. So it is quite faster controller than the other traditional bus logic, LSI logic, parallel, or SAS or para virtual and SATA controllers. So each virtual machine supports 4 NVMe controllers and up to 15 devices per controller. So it's very good. So here we should know about the NVMe, and we should use NVMe in the virtual machine with the hardware version 13. So thanks for attending this lecture, and I hope you understand. So for some queries, if some queries are there, then you can mention those queries in the comment box, and remember to like the video. Thank you very much.